Alright, in Archaeoastronomy now, we're moving off of the sun. We're going to talk about the moon. We're going to first talk about moon phases. And most of this should be familiar to you ever since like grade school, but we're going to review just to make sure. So here's the Earth here. Sun is over here somewhere. And the moon orbiting around the Earth. The reason we see different phases of the moon is because the moon is always exactly half lit up by the sun. The side facing the sun lights up half the moon. And how much of that half we see determines what phase it is. So for example, when the moon is up here, the side facing the sun is lit up, the other side is dark. It's the same thing for the Earth. This side of the Earth is dark. Okay? The sun is lighting up the other side. When we look from the Earth, we see this as a half a moon, or we call this a first quarter phase. Now when the moon is here, between us and the sun, we're looking at the dark side of the moon, and we can't see the moon at all. We call this a new moon. And that's why this is called a first quarter moon, because the moon goes around us counterclockwise, and as it goes around, it's 1/4 of the way from new moon. We always start a month from new moon. Now when the moon is over here, exactly opposite our sky, then from the Earth you see the completely lit up side of the moon, and we call this a full moon. When the moon is down here, we see the lit up side. We see a half moon as well. We're just seeing the other half of the moon. This is called third quarter. Now in between those, we have partial phases, or phases where it's not an exact equally spaced. So from new moon all the way to first quarter, we see this half is still lit up, but what we see from the Earth is we see a crescent moon. And the crescent goes anywhere after new moon but before first quarter. So anywhere in here is considered a crescent moon. It's not one specific position. Over here it's a similar thing. We have the moon here. But what we see from the Earth is we see more than a half, but not a full moon. We call this a gibbous moon. Same thing down here is we see more than a half, but not quite full. That's called a gibbous moon. My picture's not great here, but you get the idea. And then over here again we see a sliver of a moon, or a crescent moon. Alright, but we have to delineate between the moon up here, the crescent up here, and the crescent down here, and the gibbous up here and the gibbous down here. And what they do, and even the ancient people realized, was that the moon goes through phases in which it starts out, you can't see it at all, then it gets a crescent, it gets bigger and bigger all the way up to full moon. Once it hits full moon, it gets smaller and smaller and smaller until it disappears again. So on the top, anything that's getting bigger is called waxing. So these are waxing crescents and a waxing gibbous. And down here, when it's getting smaller, these are called waning. That's a waning gibbous and a waning crescent. So waxing is when it's getting bigger, waning is when it's getting smaller. Alright, now to ancient people, or the ones that were most interested in phases, the phases they were usually most interested in are when the moon was full, or the amount of time it took to change. Remember that what we call the synodic period is 29.5 days. Synodic means the period from like full moon to full, or new moon to new moon. You can pick any one. It takes 29.5 days to go around, which is why our month has 30 days. Now our problem is 30 days, or 29.5, does not go into 365, so they had to add extra days on, which is why we ended up with 31 days and our calendar got kind of all messed up. We're going to talk about calendars in a little while. But that's the amount of days. But when you get to here, when it's a new moon, you can't see it for about 2 days. So if you're really good, you can see it so it's visible for 28 of those days. For 1.5, it's too close to the sun and you can't see it. Also, we notice here that, remember, the Earth is spinning this direction. So we're looking with the North Pole sticking out. So if we look at time on the Earth, when the sun's directly overhead, this position right here is noon. Then the sun would be over the head for Herb. When Herb is up here on this part of the diagram, the top, it's 6 p.m. When Herb is over here, it's midnight. And when Herb is down here, it's 6 a.m. So time is told by Herb rotating around with respect to the sun. It's independent completely of the moon. But if you notice here, at midnight, Herb's over here, sun's on the opposite side from Herb through the Earth. Then the full moon is going to be directly over Herb's head. But when you're up here, the sun can be in the sky. If you're at this position here, you can still see these even with the sun in the sky. And I'm sure you've seen the sun in the sky in the day, the moon in the daytime sky, even with the sun out. Now what you notice is that 6 p.m., this is evening up here when the Herb's up on the top part of the diagram. So the ones up on this half of the diagram are when it is seen in the evening. When the moon is seen in the evening. The ones on the bottom half of the diagram are when you see the moon in the morning. But the full moon is great because the full moon is exactly opposite the sun. And so just as the sun sets, the full moon rises. The full moon is up all night long. It's the only phase that the moon is up all night long because it rises as the sun sets and it sets as the sun rises. So that is definitely one of the most important phases to ancient people because that one would be the light up the sky. Now there's also something else interesting about it because it's opposite. So we're still talking about the full moon here. Because it's opposite in the sky, the sun, we realized, is highest in the sky in the summertime. That's when it's at its declination of 23.5 above the ecliptic. But the moon is opposite that. So in the summertime, when the sun is highest in the sky, the full moon is actually lowest in the sky. And so your full moon is up the shortest amount of time. And it's exactly opposite in the winter. So in the winter, the full moon is highest in the sky. And it is up for the longest amount of time. Which was very nice because in the winter, around the winter solstice, when the sun is only up for a few hours a day, when it was near full moon, the full moon would be up the whole night and would light it up very well, and it was very high in the sky. So the best moons, full moons, actually occur in the winter months, not in the summer months, because it's exactly opposite the sun in the sky. All right, so for this class, I expect you to know the different phases, but we're not going to go into details. There's a lot more details that you could learn about the moon, because the most important thing is the changing of the moon and the fact that the full moon is the one that most people would signify, or most of the ancient people would put the most hedons to, because they knew the moon was there and was changing all the time. The moon is very important to some cultures, and in other cultures it seemed to be kind of ignored. The Mayan people, they had the moon, they had a god for the moon, but it really wasn't a big deal to them. But for people like the Hebrew culture and Islamic culture, their whole calendars and everything are based on the moon, especially the Islamic calendars, because they have their months, their sacred months and stuff, and the sacred months would always start exactly when they could see the tiniest crescent moon. And then as soon as they could see that crescent moon, that month would begin, and then it would end when the moon disappeared on the other side. So they would have people specifically watching for that tiniest crescent they could see after new moon phase. So they were very into the moon. So it depends on the different cultures whether they thought the moon was important or not.